Hello students, in this class we will learn about geometric progression. So before learning geometric progression, first of all we have to learn what do you mean by geometric progression. Okay, let us study about geometric progression. Suppose there are some numbers like 2, 4, 8, 16, continuing. 1 by 3, 1 by 9, 1 by 27, 1 by 81, continuing. Minus 1, minus plus 3, minus 9, plus 27, continuing. Okay. So, to understand GP or geometric progression properly, here we choose these three series. In the first series, the first term is A1, that is equals to 2. Second term A2 is equals to 4. Third term A3 equals to 8. Fourth term A4 equals to 16. And this series continues. Now, A2 by A1 is equals to 4 divided by 2 equals to 2. A3 by A2 equals to 8 divided by 4 equals to 2. A4 by A3, that is 16 by 8 equals to 2. That means any term divided by its previous term always gives a fixed value. If we follow the second example, then first term is 1 by 3. Second term A2 is 1 by 9. Third term A3 is 1 by 27. Fourth term A4 is equals to 1 by 81. So now A2 by A1 is equals to 1 by 9 divided by 1 by 3. That is 1 by 9 into 3 by 1. When this fraction 1 by 3 converts into multiplication, then we have to write the reciprocal of 1 by 3. Thus, we get 1 by 9 into 3 by 1. Cancelling these two, we get 1 by 3. A3 by A2 is equals to 1 by 27 by 1 by 9. This will give 1 by 27 into 9 by 1. This will give A3 by A2 is equals to 1 by 3. A4 by A3, that is 1 by 81 divided by 1 by 27. This will give 1 by 81 into 27 by 1. Cancelling 27 and 81, we get A4 by A3 equals to 1 by 3. That is A2 by A1 equals to 1 by 3. A3 by A2 equals to 1 by 3. A4 by A3 is also 1 by 3. That is, any term divided by its previous term always gives a fixed value. Now, if we follow the third series, then first term A1 is minus 1. Second term A2 is 3. Third term A3 is minus 9. Fourth term A4 is 27. Now, A2 by A1 is equals to 3 by minus 1 equals to minus 3. A3 by A2 equals to minus 9 by 3. Cancelling 3 and 9, we get 3. Thus, A3 by A2 equals to minus 3. A4 by A3 equals to 27 by minus 9 equals to minus 3. Cancelling 9 and 27, we get 3. Here A2 by A1 equals to minus 3. A3 by A2 equals to minus 3. A4 by A3 is also minus 3. That is, in these three example of series, we observe that any term divided by its previous term always gives a fixed value. If A2 by A1 for the first example is 2, A3 by A2 for the first example is 2, A4 by A3 for the first example is 2, A2 by A1 for the second example is 1 by 3, A3 by A2 for the second example is 1 by 3, A4 by A3 for the second example is 1 by 3. A2 by A1 for the third example is minus 3. A3 by A2 for the third example is minus 3. A4 by A3 for the third example is also minus 3. That is, in this three series, the series progressed in such a way that any term divided by its previous term always gives a fixed value. So, these examples give us the conclusion about the definition of geometric progression. Okay. Definition. If a series of value progressed in such a way that any term divided by its previous term always gives a fixed value, then that progression is known as geometric progression or GP. So, we get this definition of geometric progression depending upon the previous three series. Okay. So, the definition of GP is like that: if a series of value is progressed in such a way that any term divided by its previous term always gives a fixed value, then that progression is known as a geometric progression. Okay. In short, we can say geometric progression as GP. General form. A, AR, AR square, AR cube plus continuing plus A into R to the power of n minus 1. There is another thing about GP, that is for a GP, when a series of value progressed in such a way that any term divided by its previous term always gives a fixed value, that fixed value is known as common ratio. Okay, so for a GP, any term divided by its previous term always gives a fixed value. That fixed value is known as common ratio. So here, for the general form of GP, we write the first term as A, second term as AR, third term as AR square, fourth term as AR cube. First term A1 equals to A. Second term A2 equals to AR. Third term A3 equals to AR square. Fourth term A4 equals to AR cube. Here the common ratio is R, as A2 by A1 equals to AR by A. Cancelling A, we get R. A3 by A2 equals to AR square by AR. Cancelling AR, we get R. Okay. Since for this general form, A2 by A1 equals to R, A3 by A2 equals to R, so we can say R is the common ratio for this general form of GP. Now we can represent A by this way, A into 1. We can represent 1 as R to the power of 1 minus 1, because something to the power 0 is 1. So R to the power 0 equals to 1, and we can represent 0 as 1 minus 1. That is why we can write this 1 in this form, R to the power 1 minus 1. Similarly, we can write AR in this way, A into R to the power of 1. Nothing is present in the power, means 1 is present. So that is why we can write AR as A into R to the power 1. This will give A into R to the power of 2 minus 1, because we can represent 1 by the subtraction of 2 and 1. Similarly, we can represent AR square as A into R to the power of 3 minus 1. AR cube as A into R to the power of 4 minus 1. Okay. Now, if we follow these terms, then A1 is equals to A into R to the power of 1 minus 1. A2 is equals to A into R to the power of 2 minus 1. A3 equals to A into R to the power of 3 minus 1. A4 equals to A into R to the power of 4 minus 1. That is, this is 1, this is also 1. This is 2, this is also 2. This is 3, this is also 3. This is 4, this is also 4. That is why A R to the power n will represent an, that is nth term. An is equals to A into R to the power of n minus 1. Okay. So, this formation, that is the formation of A2, A3, A4 help us to conclude that A into R to the power of n minus 1 represents the nth term of a GP. Okay. Now, if three numbers, say A, B, C, are in GP, then by the definition of GP, we can write B by A is equals to C by B, because any term divided by its previous term always gives a fixed value by the definition of GP. That is why the value of B by A and value of C by B will be equal. So these imply B square equals to AC by cross multiplication. Okay. So if three numbers A, B, C are in GP, then by following the definition of GP, we can write B square equals to AC. Okay. Again, if three numbers are in GP, then we can let them as A by R, A, AR. Okay. Since A divided by A by R is equals to A into R by A equals to R. AR divided by A equals to AR by A will give R. Okay. So, any term divided by its previous term always gives a fixed value, and that fixed value is here R. So that is why if three numbers are in GP, then we can let them as A by R, A, AR. what is the facility of letting these three numbers by this way? Because when we multiply these three numbers, then then one unknown will cancelled out. Like a by r into ar, cancelling r, we get aq. Okay. So this thing we will discuss when we solve geometric the geometry problem progression related problems. Okay. So when three numbers are in GP, then we can let them as a by r, a and ar. Similarly, if r represents the common ratio of a GP where A, B, C, D are four consecutive terms, then we can write by the definition of GP, B by A is equals to C by B is equals to D by C equals to R. Okay. Similarly, if R represents the common ratio of a GP where ABCD are four consecutive terms, then we can write B by A, that is second term by first term, equals to C by B, that is third term by second term, equals to D by C, that is fourth term by third term, is equals to common ratio, that is equals to R. Okay. So these are the primary or basic concepts about GP. Here we choose a problem to clear our view about geometric progression. Okay. So here it is given that ABCD, that means these four consecutive numbers are in GP. Then we have to prove A plus B, B plus C and C plus D are also in GP. Okay. So let us study how we can prove this problem. Solution. Since A, B, C, D are in GP, therefore by the definition of GP, we can write B by A is equals to C by B equals to D by C. Okay. Any term divided by its previous term always gives a fixed value. That is the definition of GP. So by that definition, we can write B by A is equal to C by B equals to D by C. Okay. Let the common ratio of the GP be R. Smaller. So therefore, B equals to AR, C equals to AR square, and D equals to AR cube. Okay, because second term is equals to first term by this formula. A, that is nth term of a GP is equals to A into R to the power of n minus 1. So by this formula we can write B, that is second term, is equals to A into R to the power of 2 minus 1. A into R to the power of 2 minus 1, that is A into R. Third term C, A into R to the power of 3 minus 1, that is AR square. Similarly, A into R to the power of 4 minus 1, that is AR cube. Okay. There is another way by which we can write B equals to AR, C equals to AR square, D equals to AR cube, which is B by A is equal to C by B equals to D by C by the definition of GP, and here we consider R be the common ratio. So by that way, B by A is equals to C by B is equals to D by C equals to R. So this will give B by A equals to R, C by B equals to R, D by C is equals to R. So this will give B equals to AR, C equals to BR, D equals to CR. Now if we put B equals to AR here, then this will give AR into R, that is AR square. D equals to CR. Now if we put C equals to AR square here, then we will get AR square into R, that is AR cube. Okay, so these are similar with this. So we get B equals to AR, C equals to AR square, D equals to AR cube, where R be the common ratio. Now we have to prove A plus D, B plus C and C plus D are also in GP. That means they are like A, B, C. Again, when A, B, C are in GP, then we get B square equals to AC. Already we know about this concept. So by this concept, these three terms, that means A plus B, B plus C and C plus D will be in GP if we prove A plus B into C plus D is equals to B plus C whole square. Now A plus B, B plus C, C plus D will be in GP if we prove A plus B into C plus D is equals to B plus C whole square. Okay. So here we consider A plus B as A, B plus C as B, and C plus D as C. So by this concept, if we prove A plus B into C plus D equals to B plus C whole square, then we can say that these three terms will be in GP. So A plus B into C plus D is equals to A plus B means AR. We can replace B by AR. C means AR square and D means AR cube. We can take A as the common factor. After taking A as the common factor, the rest of the term will be 1 plus R. From the second part, AR square is the common factor. After taking AR square as the common factor, the rest of the term becomes 1 plus R. After multiplying, we get A square R square into 1 plus R whole square. So A plus B into C plus D gives A square R square into 1 plus R whole square, and B plus C whole square will give, we can replace B by AR and C by AR square. From these two terms, AR is the common factor. After taking AR as the common factor, as the common, we get rest of the term as 1 plus R. So this AR into 1 plus R whole square will give AR whole square into 1 plus R whole square. This will give A square R square into 1 plus R whole square. This implies A plus B into C plus D is equals to B plus C whole square. This implies A plus B, B plus C, C plus D are in GP. Proved. So this is the way by which we can prove these three terms A plus B, B plus C and C plus D are in GP. In problem number 2, we consider a GP where the first term is 5 and the fifth term is 405. Okay. So there is a GP whose first term is 5 and the fifth term is 405. We have to find this intermediate term, that means second term, third term and fourth term, that is X, Y and Z. Solution. Since 5, X, Y, Z, 405 are in GP, then we can consider first term A1 equals to 5, second term A2 equals to X, third term A3 equals to Y, fourth term A4 equals to Z, and fifth term A5 equals to 405. Okay. We have to find x, y, z, that is second term, third term and fourth term. So, to find any term of a GP, we have to know the first term and the common ratio. Already we know the first term, that is 5, but we don't know what is the common ratio of this GP. That is why let the common ratio of the GP be R. Therefore, A5 equals to 405 imply A1 into R to the power of 5 minus 1 equals to 405, because here the first term is denoted by A1, that is why we write A5 as A1 into R to the power of 5 minus 1 by following this formula of nth term. Okay. Here the first term is A, that is why n equals to A into R to the power of n minus 1, and for this problem first term is A1, that is why A5 is equals to A1 into R to the power of 5 minus 1. Okay. So, this imply A1 value of A1 is 5. 5 into R to the power of 4 equals to 405. This imply R to the power 4 equals to 405 by 5. Cancelling these two, we get 81. This will give R to the power 4 is equals to plus minus 3 to the power 4, because 3 to the power 4 is 81 and minus 3 whole to the power 4 is also 81. That is why we can write 81 as plus minus 3 whole to the power 4. So, this will give R equals to plus minus 3. Okay, by the formula of exponent. A to the power m equals to b to the power m, imply A equals to b. When A and B belongs to real number. Okay. By following this formula, we can write R to the power 4 equals to plus minus 3 whole to the power 4 as R equals to plus minus 3. Case 1. When R equals to 3, then x equals to A2 equals to A1 into R to the power 2 minus 1 equal to 5 into 3 to the power 1, imply x equals to 15. Y equals to A3 equals to A1 into R to the power of 3 minus 1 equal to 5 into 3 square. This implies y equals to 5 9s 45. Z equals to A4 equals to A1 into R to the power of 4 minus 1 equal to 5 into 3 to the power 3, that is 3 cube. This implies Z equals to 135. Case 2. When R equals to minus 3, then X equals to A2 equals to A1 into R to the power of 2 minus 1 equals to 5 into minus 3 whole to the power of 1, imply X equals to minus 15. Y equals to A3 equals to A1 into R to the power of 3 minus 1 equal to 5 into minus 3 whole to the power of minus 3 whole square. This implies y equals to 5 into 9, that is 45. Z equals to A4 equals to A1 into R to the power of 4 minus 1 equals to 5 into minus 3 whole cube. This implies Z equals to minus 3 whole cube will give minus 27. So 5 into minus 27 will give minus 135. So in these two cases, we get these values of X, Y and Z. Okay, so this is the way by which we can find the value of X, Y and Z.